Imagine a color so brilliant, so mesmerizing, that it was reserved only for the most powerful beings in ancient Egypt, gods and pharaohs. This was no ordinary blue. It shimmered with an almost magical intensity, illuminating the walls of sacred tombs and bringing to life the legendary statues that watched over the Nile for centuries. Egyptian blue was more than just a pigment. It was a symbol of divinity, eternity, and the boundless creativity of a civilization obsessed with the afterlife. For thousands of years, Egyptian blue stood as the world's very first synthetic pigment, a true marvel of ancient chemistry. Crafted from a careful blend of sand, copper, and natron, it was fired at high temperatures in kilns, producing a color that was both vibrant and enduring. This innovation allowed artists and craftsmen to create dazzling works that have survived the ravages of time. Yet as the great empires of Egypt crumbled and new powers rose, the secret recipe for this extraordinary pigment was lost to history. All that remained were faded traces on broken statues and crumbling temple walls, a beautiful enigma that puzzled generations. We catch glimpses of its former glory in the intricate blue inlays on Tutankhamun's coffin, and in the star-studded ceilings of the Valley of the Kings, where the pigment still glows softly after millennia. But the ancient knowledge of how to create this luminous blue was lost, buried beneath centuries of sand and forgotten scrolls. How did a civilization without the tools of modern science manage to invent something so advanced, so enduring, that it would outlast even their own dynasties? The mystery of Egyptian blue became an irresistible challenge for modern scientists and archaeologists. Their quest to rediscover its secrets became a bridge connecting the distant past to the cutting-edge technology of today. In their journey to recreate this lost pigment, researchers made a startling discovery. Egyptian blue possesses a hidden superpower. When exposed to infrared light, it glows with an otherworldly luminescence, invisible to the naked eye but unmistakable under scientific instruments. This unique property has inspired new innovations, from advanced medical imaging to energy-efficient materials, proving that the wisdom of the ancients can still shape our future. The story of Egyptian blue is not just about a lost color, it's about a relentless search, a glowing rediscovery, and the timeless connection between human curiosity and the wonders of the past. So, what is Egyptian blue? At first glance, it might just look like a striking blue powder, but there's a fascinating story behind this ancient pigment that stretches back thousands of years. At its core, Egyptian blue is calcium copper silicate, a unique man-made crystal. It holds the distinction of being the world's oldest known synthetic pigment, crafted by human hands rather than found in nature. This innovation marked a turning point in the history of color. Before its invention, blue was an incredibly rare and precious color. Artists and craftsmen relied on minerals like lapis lazuli, which had to be mined in distant lands and transported over long trade routes, making blue pigments more valuable than gold in some cases. The Egyptians revolutionized this by inventing their own blue pigment around 2600 BCE. Suddenly, blue became accessible for use in art, architecture, and religious rituals, allowing it to flourish throughout Egyptian culture. Egyptian blue colored the walls of tombs, adorned faience jewelry, and even decorated the iconic funeral mask of King Tutankhamun. Its vibrant hue became a symbol of status, beauty, and craftsmanship. In Egyptian symbolism, blue represented the heavens, the life-giving Nile, and the divine. By mastering the creation of this pigment, Egyptians brought the sacred into both daily life and the afterlife, using blue to connect with their gods and the cosmos. What's truly remarkable is Egyptian blue's durability. Its unique crystal structure made it incredibly stable, allowing its color to survive thousands of years without fading, even under harsh conditions. That's why, when we visit museums today, we can still marvel at the brilliant blue on ancient artifacts, as vivid as when it was first applied. The longevity of Egyptian blue is a testament to the ingenuity and skill of ancient Egyptian chemists, who mastered complex techniques long before modern science. Their creation of this pigment ensured that their art, stories, and spiritual beliefs would endure, standing the test of time for millennia. Today, Egyptian blue continues to preserve the artistic and spiritual visions of an ancient civilization, allowing us to witness and appreciate their legacy in all its vibrant glory. Creating Egyptian blue was a sophisticated process, requiring precise ingredients and expert control. The recipe ground limestone, copper ore, desert sand, and a flux like natron or plant ash. These were heated in kilns to over 800 degrees Celsius, a feat demanding specialized equipment and skill. Too little heat, and the reaction failed. Too much, and the mixture turned to glass. The artisans judged temperature by the color of embers, perfecting their craft through generations of trial and error. The result, a hard, glassy blue cake, ground into powder and mixed with binders to make paint. This was the world's first chemical laboratory, ancient artisans as pioneering chemists. Their iterative process was the heart of the scientific method. Egyptian blue's creation defined the aesthetic of a civilization. Their workshops were the birthplace of material science. Thousands of years later, modern scientists became detectives, piecing together the lost recipe of Egyptian blue. They analyzed pigment samples from artifacts using electron microscopes and X-ray diffraction, revealing its chemical fingerprint. With the formula in hand, researchers recreated the pigment in labs, experimenting with sand, copper, and lime. The hardest part was replicating ancient kiln conditions. Temperature and oxygen levels had to be just right. Countless trials revealed how sensitive the process was, deepening respect for ancient craftsmen. When lab-made samples matched the crystal structure of ancient pigment, the code was cracked. The rediscovery wasn't from a scroll, but from following scientific clues left by the Egyptians. It was a triumph of archaeology and chemistry. This process bridged the gap between ancient innovation and modern science. The lost art was revived, not by chance, but by methodical investigation. Egyptian blue's secret was finally unlocked. Recreating Egyptian blue revealed even more the Egyptians could control its shade. Coarser ingredients made a darker blue, finer ones, a lighter hue, showing intentional artistic choices, not just aging. This sophistication meant pigment makers could tailor colors for specific uses, like skies or royal garments. The flux, natron or plant ash, was crucial. It lowered the melting point, making large-scale production possible. This clever shortcut showcased Egyptian problem-solving. Modern scientists watched the pigment form in real time, seeing ancient chemistry come alive. These experiments confirmed theories and revealed the artisan's technical mastery. Egyptian blue's creation was both art and science. The process was a window into ancient innovation. In 2009, a stunning discovery changed everything. Egyptian blue, a pigment used by the ancient Egyptians thousands of years ago, was found to glow brilliantly under infrared light. This revelation opened up a whole new world of possibilities for scientists and historians alike. Researcher Giovanni Verri made this breakthrough when he noticed that, under red light, the pigment emits a powerful infrared glow, completely invisible to the naked eye, but easily detected with special cameras. This means that what looks like an ordinary blue pigment to us is actually hiding a secret energy waiting to be revealed. No other ancient pigment behaves this way. While other colors simply reflect or absorb visible light, Egyptian blue uniquely transforms light into a hidden signal, setting it apart from every other pigment known from antiquity. This remarkable property allows scientists to detect traces of Egyptian blue on artifacts, even when the original color has faded away or is completely hidden beneath centuries of dust and grime. Thanks to this, lost details on statues and paintings, features that had vanished to the naked eye, have been rediscovered using advanced infrared cameras, bringing ancient art back to life in ways never before possible. The secret behind this superpower lies in the unique arrangement of copper ions within the pigment's crystal structure. This microscopic architecture makes Egyptian blue an incredibly efficient emitter of infrared light, a property that modern scientists are only now beginning to fully understand. The ancient Egyptians, of course, had no idea about infrared light or nanotechnology, yet through their ingenuity they created what we now recognize as a high-tech nanomaterial, millennia ahead of its time and still astonishing scientists today. Today, this hidden glow has become a vital tool for art historians and conservators. It helps them uncover secrets, authenticate artifacts, and better understand the techniques of ancient artists. Egyptian blue's superpower bridges the gap between ancient art and modern science, connecting the creativity of the past with the technology of the present. Its unique luminescence reveals lost stories, hidden details, and forgotten craftsmanship, allowing us to see ancient masterpieces in a completely new light. The pigment's secret waited patiently for thousands of years, hidden in plain sight, until science finally unlocked its hidden glow, forever changing how we see the art of the ancient world. Egyptian blue was more than decoration. It was a symbol of transformation and eternity. Its creation mirrored Egyptian creation myths, turning raw earth into celestial blue. Used in tombs, it represented the eternal heavens and the promise of rebirth. The pigment was also an economic powerhouse, traded across the ancient world. Its unique chemical signature helps archaeologists trace trade routes and cultural connections. Finding Egyptian blue at a site reveals stories of ancient exchange and influence. It was a prized commodity, much like silk or spices in later eras. The pigment is both a witness and a narrator of history. Egyptian blue connects civilizations across time and space. Egyptian blue's story continues in the modern world. When broken into nanosheets, it becomes a powerful near-infrared emitter, useful in medical imaging, security inks, and telecommunications. In medicine, these nanosheets could help doctors see deeper into the body for better diagnoses. Security industries use its unique glow for anti-counterfeiting features on documents and currency. Even telecommunications may benefit from its stable infrared signals. The pigment's ancient chemistry is now a modern solution. Innovation sometimes means rediscovering the past. Egyptian blue's legacy is shaping the technology of tomorrow. The pharaoh's color is now a tool for the future. Egyptian blue's journey from pharaoh's kilns to modern labs is a testament to human ingenuity. The ancient Egyptians were true scientists, their work inspiring us even today. Rediscovering this pigment shows the power of combining art and science. Collaboration between disciplines unlocked its secrets and paved the way for new innovations. Preserving artifacts preserves knowledge. Each piece holds untapped potential. Egyptian blue's story is about light, visible and invisible, and the achievements of a remarkable civilization. The past is a living source of inspiration and discovery. Ancient genius echoes in our world, teaching us to look deeper. Sometimes the brightest ideas are hidden in the colors of history.